Today is 3rd January 2024. It is AS Physics and we are studying kinematics. We have done its one class yesterday and it is its second class in which we are going to start free fall motion. What is the meaning of free fall motion? Free fall motion means if an object falling down or if an object is thrown upward and only force of gravity is acting on it. If only force of gravity acting, no air resistance, no upthrust, then such a motion is called free fall motion. Free fall motion means the motion in which the object experiences only the force of gravity. It is called free fall motion. In free fall motion, if an object is drop, when an object is drop, then its initial velocity is considered zero and its velocity keep on increasing. So acceleration is considered positive and this acceleration is always 9.81 meter per second square, and this acceleration is known as acceleration due to gravity. That is why it is denoted by small g. When an object is drop, then initial velocity is zero and acceleration is considered 9.81 and it is positive. But if an object is thrown upward, then obviously its velocity keep on decreasing. If it is thrown vertically upward, then obviously its velocity is decreasing. So its final velocity will be zero. And as velocity is decreasing, so there will be negative acceleration that is known as deceleration or retardation, and we will use its value minus 9.81 meter per second square. So note down these two key factors when we are solving this question. If an object is dropped, then initial velocity is considered zero and g is plus 9.8. And if an object is thrown vertically upward, then final velocity is zero and acceleration is considered minus 9.8 meter per second square. And equation of motion, we will use same equation of motion. The first equation of motion is v is equals to u plus at, but I am writing gt instead of a. Yes, we will use first equation of motion. First equation of motion, v is equals to u plus gt, and actually I have replaced acceleration by g. Acceleration is replaced by g and it is first equation of motion. In the same way, second equation of motion, s is equals to ut plus half at square, but in the same way I am replacing a by g. And the second equation of motion is expressed in this way as well, vt minus half gt square. It is second equation of motion. Then we have third equation of motion. So third equation of motion is 2as equal to v square minus u square, and a is replaced by g. And if it is more better if we use height instead of distance, because when an object is moving downward or if an object is moving upward, then we call its vertical distance as height. So I have replaced distance by height and acceleration by g. So it is first equation of motion, v is equals to u plus gt. It is second equation of motion, h is equals to ut plus half gt square, And it is third equation of motion, that is 2gh is equals to v square minus u square. So now we are going to use these equations for today's class. So let's start the questions from P1, that is unit 3.1. And if you have noted these equations, then we can start our questions. Beta Afra, have you noted these equations? Okay, beta, okay, I'm waiting. But no necessary to note down more. If you note only this one, when an object is dropped, if an object is dropped, then initial velocity is zero. It is enough. Acceleration will be plus 9.881. If an object is thrown upward, then final velocity will be zero and acceleration will be minus 9.81. And then you note down these equations, then it is enough. And right now we are studying free fall motion, and free fall motion means the motion in which only the force of gravity is acting on an object. It is known as free fall motion. We do not use fourth equation, we do not use constant speed equation, because in free fall motion there must be acceleration, that is 9.81 meter per second square. Okay, beta. And now we are starting questions from P1 book, and the P1 book is here. Yes. And now let's start questions. Question number 2. Question number 2. Question number 2. A ball is thrown vertically upward. Vertically upward. Beta, if any object is thrown vertically upward, so vertically upward means final velocity will be 0, gravity will be minus 9.8. It reaches maximum height 12.7 meter. Air resistance negligible means it is free fall motion. Calculate time. We have to calculate time. So if you are given height and you have to calculate time, then obviously you should use h is equals to vt minus half gt square. It is second equation of motion, and the object is thrown upward. Object is thrown vertically upward, and you know that in upward motion final velocity will be zero. That is why I am using second equation of motion with final velocity. So final velocity is 0, height is 12.7, final velocity is 0, g is minus 9.81, and you have to calculate time. Okay, but the height is 12.7, final velocity is 0, g is minus 9.81, we have to calculate time. And now 12.7 equals to minus minus, it makes plus, 9.8 divided by 2, it makes 4.9 t square. 4.9 is shifted on the other side, and if you calculate its square root with division, then I think answer will be 1.61. Okay, beta. Height is 12.7 divided by 4.9, then taking its square root, then you will get the time. Time is 1.61. But this time is only for upward motion, because we are dealing only upward motion right now. We are dealing only upward motion right now, in which the object is moving upward. But they are asking what is the total time for which the ball remains in air. It means they are asking total time. Total time means the time for upward motion as well as time for downward motion. They are asking total time. So 1.61 is not the answer, because 1.61 time is only for upward motion. So if you multiply with 2, then the answer will be 3.22 seconds. And actually it is the right answer. Right answer is not A, right answer is B. Why? because it is the total time. Because it is the total time. I think you have noted. हाँ बेटा. जी बेटा. in this question in this question but we have to calculate time and we are given height. So I taught you in the last class, when distance and time are given, when height and time are given, then we use second equation. If time is not considered, then we use third equation. If height is not important, then we use first equation. So we have three equations and the same concept which we have used in the last class. First equation, when distance or height is not given. Second equation, when height and time are given. In this question you are given height and you have to calculate time, so I used second equation of motion beta. Is it clear? The same concept which we used in the last class. Okay beta. And now we are solving question number 3. In this question number 3, a lead sphere is released from rest. Okay, released from rest and long way above the surface of a planet. Planet means we are not on Earth. This is another planet where acceleration due to gravity we do not know. Okay, it is not 9.81. We are not on Earth. We are on another planet. So we do not know acceleration. Okay, so the question is, after 4 seconds, the lead sphere has covered a distance of 3 meter. We are given two variables, time and height. हाँ बेटा Afra, if you are given time, if you are given height, then which equation should we use? Afra, we are second equation of motion. Yes, you are right. Sir, we should use second equation of motion, and it is question number 3 which I am solving here. And we are on another planet. We are on another planet. If we are on another planet, then the question is, the sphere is drop, initial velocity is 0, and in 3 4 seconds it has covered a height of 3 meter. It has covered a height of 3 meter. So I'm using second equation of motion. H is equals to ut plus half at square. Height is 3 meter. Initial velocity is 0. Acceleration we have to calculate. Time is 4 seconds. So 3 upon 2 1 the 2, 2 8 the 16. So acceleration is 3 upon 8. This is the acceleration on another planet. This is acceleration due to gravity on another planet. It is not on Earth. So by using first sentence, 3 meter height in 4 seconds. 3 meter height in 4 seconds. So acceleration is 3 upon 8. Acceleration is 3 upon 8. And now what is the question? So the question is, how far will the sphere have fallen in 20 seconds? The question is, in 20 seconds, how much height the object has fallen? So I'm using again same equation. H is equals to ut plus half at square. As the object is released, so initial velocity is 0. Height we have to calculate. Acceleration, sir, we have calculated acceleration earlier. Acceleration is 3 upon 8, and the time given in this condition is, it is 20 seconds. So if you solve 20 square and then you solve half 3 upon 8, then you will get the answer. Abta, can you tell me what is the answer? Or I am using calculator to solve the answer? I am using calculator. This is calculator, and I am writing 200 square, that is, sorry, 20 square means 400, 400 multiplied 3, it is 1200. 1200 divided by 16, so the answer is 75 meter. Answer is 75 meter. Okay, but in this question, we are not on Earth. In this question, we are on another planet. That is why I cannot use G as 9.8 meter per second square. So I have used second equation of motion to calculate A, and after calculating A, I have calculated height. Avata, have you noted? Have you noted? ठीक है बेटा. अच्छा जी, question number 4 we cannot solve right now because question number 4 is very difficult question. We will solve it later. And now solve question number 8. Now we are solving question number 8. Beta, question number 8. In question number 8, a rock on the surface of Mars. Again, we are not on the surface of Earth. We are on Mars. Okay. A rock on the surface of Mars is projected vertically upward. Okay. The object is thrown vertically upward. If an object is thrown vertically upward, then obviously final velocity will be 0. And initial speed is 9.4. Initial speed 9.4, final velocity 0, and the height is 12 meter. The question is, what is acceleration due to gravity on the Mars? We have to calculate acceleration due to gravity on the Mars. Hi, but Afra, can you tell me in this question no time is given? Then which equation should we use, Afra? Which equation should we use? Yes, it is third equation of motion, 2a s equal to v square minus u square. We have to calculate acceleration. Height is given 12 meter. Final velocity is 0. Initial velocity is 9.4. And I am using calculator to give you answer, and you should note down the calculation. The calculation is 9.4 square divided by 12 to the 24. So the answer is 3.68, and you can round up this value to 3.7 meter per second square. It is acceleration due to gravity on the surface of Mars. It is acceleration due to gravity on the surface of Mars. जी बेटा, have you noted? बेटा, have you noted? And after question number 8, now question number 12 and question number 4 are of same type. Now I am solving question number 13. Question number 13, beta. Question number 13, a hot air balloon. No, no, no. Question number not 13. Question number 13 and 4 are of same type. We are solving question number 12. Question number 12 is a girl throws a ball vertically upward. Okay. A ball is thrown vertically upward, and it takes 3.2 seconds to return to her hand. It is the double time. It is time of upward motion plus time of downward motion. We are given total time 3.2. We are given total time, that is 3.2, but we should divide by 2 to calculate one direction time. and one direction time is 1.6 second. Okay, so only upward time is 1.6 seconds, so I am erasing downward motion. Only we are dealing upward motion. So question number 12, a girl throws a ball vertically upward. If an object is thrown vertically upward, then obviously final velocity will be 0. Time is 1.6 second. The question is, what is its initial speed? What is its initial speed? And it is not mentioned where are we. It means we are on earth, and if we are on earth, then acceleration will be minus 9.81. It is not mentioned we are on Mars, it is not mentioned we are on earth. It means we are on earth. So using first equation of motion, v is equal to u plus gt. Final velocity is 0. Initial velocity we have to calculate. Acceleration 9.81. Time is 1.6. Time is 1.6. So 9.8 multiply 1.6. So the answer is 15.68, and 15.68 means 15.7. Initial velocity is 15.7. It is question number 12. If you have noted, then okay. Then we will start next question. Otherwise, I am waiting. Okay, beta. And after question number 12, question number 13, we cannot solve today. We must solve it tomorrow. Now question number 12, now question number 14. In question number 14, a stone is projected vertically upward. Its initial velocity is 15 meter per second. What is its maximum height? You have to calculate its maximum height. And you know that if an object is thrown vertically upward, then obviously final velocity will be 0. Acceleration will be minus 9.81. So no time is given in this question. So we can use third equation of motion. 2gh equal to v square minus u square. You have to calculate height. So final velocity is 0. Initial velocity is 15. Gravity is 9.81. Then you can solve height. It is very simple question. Now I am not using calculator to give you answer. It is very simple question. If you have noted, then we will move forward. After question number 14, I am searching next question. Okay, okay. And now I am solving question number 26. It is a good question. Question number 26. In this question number 26, there is a deep well, and in this deep well, consider here is water, and a person at the top of the well drops a heavy stone. Okay, the object is dropped, and as the object is dropped, then obviously its initial velocity is 0. It is a deep well, and its initial velocity is 0, and the height, sorry, or the depth of well, it will be h, it is equal to 78 meter. So the stone which is dropped, it will cover 78 meters distance to hit the water surface. Okay. So if I ask you how long will it take to hit the ground, sorry, to hit the water surface, I am calculating time and I am writing this time as t1. I am interested to calculate time, and you know that if an object is falling downward, then acceleration will be plus 9.81 meter per second square. हाँ बेटा, you are given height, you are given you have to calculate time. Afra beta, which equation should I use to calculate time? H equal to, but I am waiting. Afra, ut, we should use ut because initial velocity is zero beta. Initial velocity is zero, so it is second equation of motion. Ut plus half gt square, u is zero, time will be zero. Obviously I should not write if it is whole zero, so I should solve only this factor. Half g is 9.81, we have to calculate time to cover a depth of 78 meter. So 78 divided by 9.8 divided by 2, it becomes 4.9. So I have shifted 4.9 on the other side. So I'm solving with calculator. You should note down this calculation. Under root 78 divided by 4.9. So the answer is 3.98. 3.98 second. It is the time to hit the stone with water surface. When the stone is dropped, when the stone is dropped from the top of the well, the stone will hit the water surface in 3.98 seconds. And as the stone hits the water surface, it produces sound. At this sound will travel in all possible direction. But the question is, how long? If you read the question, how long? Yeah, what is the time interval between the person dropping the stone and hearing it hitting the water? So now I have to calculate the time to listen, to hear the um sound of hitting water surface. So for this upward green arrow, I should use distance is equals to velocity into time, and it is for sound because the speed of sound remains constant. In free fall motion, it is not changed. So distance, it is 78 meter. The speed of sound, it is constant. That is why I am using this equation. Speed is 330 and times are time we have to calculate, and I am calling this time as t2. So if I divide 78 by 330, so it is the time of sound. Sound taking 0.23 seconds to travel from its beginning. When the sound is produced, when the stone is hitting the water, the sound is produced this, and from this to listen the sound, it takes 0.23 second, and we have to calculate total time. So the total time will be equal to their sum, 3.98 plus 0.23. So if I add 3.98 with this number, then the final answer is 4.21. 4.21. Total time is 3.98 plus 0.23. So total time becomes 4.21 second. Total time 4.21 second. It is the total time. So this question is a mixture of free fall motion as well as speed of sound is constant. When the speed of sound is constant, then I can use S equal to V into T. I am using S equal to V into T. and the charging of my tablet is ending. So I am connecting charger and I have switch off my microphone. So this question is completed. And I think now we can solve these two questions which we have left in the beginning. It is question number 4 because these are final questions. Okay, but let's start question number 4. It is a very difficult question, I believe. The question is, consider it is a building and this building at seashore. This is sea. And the question is, a stone is thrown vertically upward. A stone is thrown vertically upward. A stone thrown vertically upward. Okay. From a point that is 12 meters above the sea level. This is sea and the throwing point is 12 meters above. Throwing point is 12 meters above the sea. And it then falls into the sea. It then falls into the sea. Air resistance is negligible, and the question is at which speed the stone thrown upward? They are asking initial speed. They are asking initial speed. Okay, it is the question. This question can be solved in two ways. The method number one, sir, if we solve first only upward motion, then we will solve downward motion, then the method will be so lengthy and it is an objective. So we cannot attempt such a long method. So I am teaching you a different method in which I am dealing upward motion as well as downward motion simultaneously. Before question number 4, I taught you we deal either only upward motion or we deal only downward motion. Before question number 4, I taught you you should deal either only upward motion or you should deal only downward motion. But in question number 4, we are going to deal upward and downward motion simultaneously. The method is, sir, we are given height, we have to calculate initial velocity, and we are given other thing. Let me check. Any other quantity? Yes. A stone is thrown vertically upward, 12-meter height. Time is 3.4 second. We are given time as well. And this is the total time. It is the total time for upward motion as downward motion. So the time is 3.4 second. The time is 3.4 second. Height is 12 meter. So if I use h is equals to ut plus half gt square, and we are dealing simultaneously upward and downward motion. So remember, if you are dealing upward and downward motion simultaneously, and if you are given height below the throwing point, it is the launching point, it is the launching point, and you are given height below the launching point, then this height is considered negative. This height is considered negative if the throwing height, if the throwing height is 12-meter and this height is below the point of throw. If the height is below the point of throw, then this height is considered negative. So I am taking height minus 12. Initial velocity we have to calculate. Time is 3.4 second. The object is thrown upward, thrown upward. So g is considered minus 9.81 and time is 3.4 square. And now I am solving. Minus 12 is equals to 3.4 u minus. And now I am using calculator. I am using calculator. 3.4 square multiply 9.8 divided by 2, it is 4.9. So it becomes 56.64. And when this number is shifted on the other side, it becomes plus. It becomes plus. This 56 becomes plus. And now I'm solving. This is seawater. And 56.644 minus 12. Then the answer is 44.64 divided by 3.4. Then you will get the answer. So 44.64 divided by 3.4. So the answer is 13.1. So the answer is 13.1. And this question is difficult. That is why I was avoiding this question. And the new concept in this question is, if you are dealing upward and downward motion simultaneously and height is below the point of throw, if the height is below the point of throw, then height is considered negative. Height is considered negative when the height is below the point of throw. And now I am teaching you another of same kind question, question number 13. But I am teaching you question number 13. It is of the same type. It is question number 13. Yes, it is question number 13. In question number 13, read the question, beta. A hot air balloon is moving vertically upward with a speed of 3 meter per second. Okay. It is question number 13. It is question number 13. Consider this is hot air balloon. Consider this is hot air balloon, and this hot air balloon is moving upward. Okay, but this hot air balloon is moving upward. It is moving upward, and its velocity is 3 meter per second. Okay. Acha beta, if this balloon is not moving upward, if it is not moving upward, and if you drop an object from the balloon, if the balloon is stationary, if the balloon is stationary, when you drop an object from the balloon, then the object will move downward. If the balloon is stationary, if the balloon is stationary and you drop an object from balloon, then the object will fall down. But if the balloon is moving upward, if the balloon is moving upward, then due to inertia, then due to inertia, when the object is dropped, when the object is dropped, then this object will move initially upward, then it will move downward. It is a new concept, I think, for you. Sir, if the balloon is stationary and you drop an object, then object moves downward. If the balloon is stationary, you drop an object, the object will move downward. But if the balloon is ascending, if the balloon is moving upward, then due to inertia, when you drop an object, then the object rises upward, then fall down. Then the object rises upward, then fall down. It is due to inertia. Note down beta this concept. Note down this concept. If balloon is at rest, an object drop, an object drop, it falls down. It is very simple. If balloon moving upward, If balloon moving upward, object dropped, object dropped due to inertia, due to inertia, it rises up, then fall down. It is the main confusion. If the balloon is at rest, the drop object always fall down. If the balloon is moving upward and you are dropping an object, then object rises up, then fall down. It is due to inertia. It is due to inertia. And if you have noted this concept, then I'm going to solve the question. In question number 13, a hot air balloon is moving vertically upward. A sandbag is dropped. It takes 5 seconds to hit the ground. It takes 5 seconds to hit the ground. Okay. 5 seconds to hit the ground. Initial velocity 3 meter per second. You have to calculate time. You have to calculate height. The question is, what is the maximum height? What is the height of balloon? Sorry, what is the height of balloon? The question is, what is the height of balloon? It means you have to calculate this height. You have to calculate this height. What is the height of balloon from which the sandbag is dropped? You have to calculate height. Okay. And it is the same kind question in which the object is moving upward and height is below the point of throw. You are the object is moving upward, starting point moving upward, and height is below. So this height should be considered negative. And the same equation ut plus half gt square. And in this question, if you do not use minus h, then the answer will be in minus. So it is very simple question. If you do not use minus, then it has no effect. Initial velocity 3, time is 5 seconds, acceleration, sir, minus 9.8 as it is moving upward, and time is 5 square. Okay, but now I am solving. 3 5 is 15 minus 4.9 into 25. 9.8 divided by 2, 4.9. 4.9 multiply 5 square, that is 25. It is 122.5. And now you can see, if you do not write minus h, if you do not write minus h, then height will be negative. But I am writing h minus, so I have no difficulty. 15 minus 122.5, the answer is minus 107.5. So minus cancel out from both sides. So height can be approximated 108 meter. So height can be approximated as 108 meter. So but in this question, if the balloon is at rest, then the drop object moves downward. If the balloon is moving upward, when the object is dropped, then due to the inertia, the sandbag first rises up, then fall down, and its total time is 5 seconds. Initial velocity is 3 meter per second. It is the speed of balloon. Height I am taking negative, and if you do not take height negative, then obviously height answer will be in minus. So you can final answer in positive form. So this question is very simple, in which if you do not write minus, then the final answer will be itself minus. Acha, beta, this question is completed, and I believe and I should stop this class because this is enough free fall motion. So I am stopping recording.